Mighty. Mighty. All right. We are all set. Hi, guys. Hello, guys.
Hello, sir.
Hi. Sorry for being late, guys. Hey, I'm coming from work, and today my transport delayed me, so
Oh,
I
sorry.
am late. But anyway, I'm here. I came running to join you guys. How are you? Okay.
Fine.
All
Fine.
right. So for today, guys, we still continue with our trig, and I am hoping that now we are actually trying to conclude trigonometry. So there's a part that said Desmond requested me to do, and that is trig identities. Trig identities. So today we are going to look at two identities for grade 12. We are going to look at one. We are going to look at the compound identity. We are going to look at number 2, the double angle identity. So these are the identities for grade 12. Otherwise, for grade 11, we have other two identities that are there for grade 11, right? So when you're working with identities, guys, the prior knowledge that we need, obviously, it's working with algebra. We know how to work with algebra. Number 2, the prior knowledge that we need is actually the identities for grade 11. At grade 11, we have two identities, which are the quotient identity, which is the tan identity, and we also have the square identity. Right, so today we are looking at compound identity and double angle identities. Okay, so before we go to that, guys, somebody was speaking. Okay, thank you. So for grade 11, from grade 11, we have two identities that we actually looked at. Number 1 was the quotient identity. So I'll write identity, ID for identity. Right? The quotient identity was the identity for tan, which says sine x over cos x is equals to tan x. I think this one we know it. And the inverse of this one says cos x over sine x is equals to 1 over tan x. So it's like we have turned it upside down. Cos x over sine x is equals to 1 over tan x. So that is the inverse of that. Okay, this one is called the quotient identity. Then last time when we were talking about, I can't remember, was it the general solution? We actually talked about this one. And we also talked about number 2. We talked about the square identity. And the square identity, I still remember I talked about it, which says sine squared a plus cos squared a is equals to 1. Then from there, guys, I indicated to say this one can be manipulated in a number of ways. For example, we can make sine squared a subject of the formula, which is going to be sine squared a is equals to 1 minus cos squared a. Then we have, making cos squared a subject of the formula, we have 1 minus sine squared a. So it means whenever we see 1 minus cos squared a, it is the same as sine squared a. Whenever we see 1 minus sine squared a, it is the same as cos squared a. And whenever we see 1, we know that it's the same as sine squared a plus cos squared a. Or where we see sine squared a plus cos squared a, it is the same as 1. Right? It is very, very important to know that we should know this is equal to that, or we should know that 1 is equal to sine squared A plus cos squared A. And we should also know that sine squared A is equal to 1 minus cos squared A. And when we see 1 minus cos squared A, we should know that it's the same as sine squared A, and cos squared A is equal to 1 minus sine squared A. And when we see this, we should know that it is equal to that. So this is very important, guys. Okay? So now I'm going to start with the compound angle identities. This is now grade 12. Compound angle identities. Compound angle identities. Right. Okay? We have 4 compound identities. I still remember, I assumed that you had done this, and I still remember I once mentioned COCO CC, CICO COSI. Right. So cos A minus B. This one is called the compound identity. This is where it all starts. The proof of this one, I'm not going to talk about it because it's very, very lengthy, and it involves drawing a diagram on the Cartesian plane, of which it confuses people. However, it's not always examinable. It is examinable, they say so, but they don't always ask about it, right? So I am going to talk about the proofs of the other one because they are examinable as well. So cos A minus B is equals to cos A cos B. Then this cos, it changes. So I'm going to say plus sine A sine B. Right. So when you're writing, you should write continuous. Only here is my space. That is not enough. So you see that cos, when you're having a negative in between here, we have a what? A positive. So cos, just know that it's cos, sine. So I call it COCO CC for us to remember. Okay? Then we have cos A plus B, which is equals to cos A cos B minus sine A sine B. So we have seen that inside there we have a plus, right? So here we have a minus. So we should note that when it's a positive here, then here we have a what? A minus. That is very, very important. Okay, so the other one that we have, it's sine A minus B. Sine A minus B. Now for sine, it changes to CICO COSI. I think it's funny, CICO COSI. And the sign remains the same. So it's sine A cos B minus cos A sine B. CICO COSI. CICO COSI. Then for sine A plus B, it is equals to sine A cos B plus cos A sine B. So we see that for sine, the signs are the same. You can actually note it that we actually have a minus here and also a minus there. We have a plus there.
Hello, sir. The screen is no longer visible.
What happened with my video? It actually.
We don't know. It just disappeared, and we were not
Okay.
hearing you.
All right, now it's back, right?
Yes, now
it back?
it's back. Yes, it's back.
Oh,
We can
oh,
see, we
okay.
can hear.
All right. So, guys, what is important is for negative, for cos, when you're having a negative, you're having a positive there, positive, negative there. But for sine, negative, negative, then positive, positive. Okay. So, guys, on these identities, you are required to prove. For example, I am going to give you one proof, formal proof that is actually required. Right? Here we have given cos A minus B is equals to cos A cos B plus sine A sine B, my space there, plus sine A sine B. Prove that cos A plus B is equals to cos A cos B minus sine A sine B. So the proof comes like this. In the examination, it comes like this. Okay? So remember that we are given this. This is what we are given, and we are required to prove that. Okay? So what am I going to do? I'm going to wrap this part here. Then I will continue from there. Okay? So we want to prove the identity of, I'm going to write it in red, the identity of cos A plus B. But here we are going to use something that is having a negative. So how do we get a negative here if we are having a positive? How do we get a negative? Right, it's simple, guys. Remember that to get a positive, it is a negative and a negative. So this is the same as cos A minus negative B, like that. Guys, do we agree that if we're having a negative and a negative there, we get a positive? Can I have a response? Jackie?
Yes, sir.
Yeah.
Yes, a negative and the negative gives us a what? A positive, right?
Yeah.
Yes.
Yeah.
Okay. So now what I'm going to do, I am going to put negative B in brackets like that. Right? Do we agree? It's still negative and negative. It gives us what? Positive. Okay. So now using this identity, we now have cos A minus the negative B, right, which is equals to, we are having a negative, so we are going to use this expansion, right? Okay, here we were having B, but now here we are not having B. What are we having here? Somebody respond. What are we having?
Negative B.
Negative B. Okay, so let's go with it. So it's cos A. Cos, where there was B, what am I going to substitute by now? Negative B.
Minus B.
Yes, negative B. Plus sine A. Then sine of what? Negative B. Okay? Right. So now I'm going to continue. So I'm going to ask you a simple question. Guys, I want a response. Which quadrant is negative B? Guys, which one?
It's the second quadrant and it's the second and the third quadrant.
It's not the second and the third quadrant. We are not dealing with what you call it.
Quadrant.
It's in the fourth quadrant. But guys, I hope you have learned that if you are dealing with negative angles, we don't know which quadrant is a negative angle. So we have to reverse it so that it becomes positive. By reversing, what do we do? All negative angles add 360 degrees. Altogether, all negative angles add 360 degrees so that you can understand which quadrant it is in. So if we add 360 degrees in negative beta, we are going to get negative b plus 360 degrees, which is the same as 360 degrees minus b, right? So now here we are going to deal with the reduction. Are we together? We are going to deal with what? A reduction. Okay, so reduction is in such a way that here it's just theta, here it's 180 minus theta, here it's 180 plus theta, here it's 360 minus theta. Or remember that angles are measured in a clockwise direction. So once you start measuring in the anti-clockwise direction, you start getting what? Negative angles. All together? You start getting what? Negative angle. So if we measure going in the clockwise direction, we get negative angle. If we measure going there, anti-clockwise, it's positive angle. So we don't want to deal with negative angles. So any negative angle, add 360 for reduction. So this one, now, negative beta is in the fourth quadrant. So this is going to be equals to cos A. Cos in the fourth quadrant, is it positive or negative? Cos in the fourth quadrant, it is positive, right? So cos negative beta is going to be the same as cos what? Cos beta. Right? Then plus. Then sine, okay, let me wrap this one so that I can have more space. Cos A, cos what? B. Right. Plus sine A remains sine A. How about this one? Which quadrant is it? Negative beta? It's in the fourth quadrant. Right? So sine in the fourth quadrant, is it positive or negative?
Negative.
Negative.
Negative. So remember the negative, it comes outside here. So it's negative sine what? Sine B. Like that. Why did I put brackets? Because we are multiplying. So this is going to be equals to cos A, cos B, then positive sine multiplied by negative sine. What we get? Positive times negative, we get what? Negative. Then we have sine A, sine B. Then it came out. So we know that this one is the same as that. So this one is equals to that. Did you get that? So it's a matter of knowing that positive is a negative and a negative. Negative and negative. Then we put the letter, this one negative beta, in brackets like that. So we have our negative. So we use that expansion there, which is going to be cos A, cos the angle that we are having there is no longer B, but it's negative B. So cos negative B. Then plus, because we are having a negative there, plus sine A, sine of negative B. Then we used our knowledge of reduction that if it's negative and it's cos there, then this is fourth quadrant, and cos in the fourth quadrant is what? Positive. Then we have this positive. Then we have our plus there. Sine A is already reduced. Then now sine in the negative in the fourth quadrant, it is negative. Then reducing this one becomes negative sine B. Then we have cos A, cos B minus sine A, sine B. That is the proof. If you look at this proof, it makes sense. Positive, negative, negative. We are given this, we want to prove this. So we want to have a negative. So how do we have a negative? Negative, negative gives us a what? A positive. Then you put the letter in what? In brackets. So we use that until we get to our answer. Okay? Right? Another proof that can come, guys. Another proof that can come. I'm going to do one for sine. Okay? One for sine that can come is given cos A minus B is equals to that. Then they will say, oh, any questions here? Sorry, I rubbed. Okay? Given that, prove that sine A plus B is equals to a sine A cos B, then plus cos A sine B. Prove that. So this is what we want to prove. Okay? Right? This is what we want to prove. So I'm going to write the other one in red. Prove sine A plus B, right, like that. Okay. Now, guys, we are given sine. We want to prove sine, but we are given cos. So my question is, how do we go to cos? How do we go to cos? Can somebody tell me, how do we interchange between cos and sine? Somebody who remembers?
I think we're gonna use minus 90.
We're gonna use the co-functions. We're gonna use 90 minus, right? Okay, so this is going to be the same as, this one is the same as cos 90 minus A plus B. So we take A plus B as one angle. Ne? Remember that co-functions, cos 90 minus A plus B becomes sine A plus B. Right? From, we know that cos 90 minus A or minus theta is equals to sine theta. Then sine 90 minus theta is equals to cos what? Cos theta. We call this one what? Co-function. I would love to prove to you where this one came from, but I won't prove to you unless if I'd done this one with you, I was going to tell you how or where to get it from. Okay? So now it is important to know that to change from sine to cos, we now use what? We now use the co-functions. So we got that. So now, what do we have? Now just remember to change cos 90 minus A plus B, right? Okay, don't forget to say in the bracket there is going to be minus A, okay? Then negative times B is also going to be minus what? Minus B. Then you close the bracket. Okay? Don't forget that we have a negative here and we have a bracket. So it means the negative is going to multiply everything in there in the bracket. So we end up in cos 90 minus A minus B. Then group such that here we have 90 minus A in bracket. Okay, so now we are going to use this expansion. So this is going to be equals to, I want to create space here, minus B. So this is going to, we are using that expansion, right? So we have a negative in between. We have equals to cos 90 minus A, then cos B, then plus sine 90 minus A. Then underneath there, because of my space, I'm going to write what? I'm going to write, what do I write? Sine what? Sine B. Yes, because we have this angle and that angle. Okay, so don't forget that cos 90 minus A, what does it give us? Cos 90 minus A, somebody tell me. It's now a co-function, this one, because we have 90 minus A. What does it give us?
Sine A.
is going to give us sine A. Right? Cos B doesn't change. Then sine 90 minus A, what does it give us?
Negative cos.
This one, 90 minus A, is in the first quadrant. 90 degrees,
A.
90 minus A comes this side, plus
Cos A.
goes that side. So it's in the first side. So it's going to give us what? Cos
Cos
A. They also sine what? Sine B. So you see, we have managed to prove. So this one is the same as that. So it means sine A plus B is equals to sine A cos B plus cos A and B. Do you see that? That is another formal proof, and it's examinable. They can ask the first one about cos A plus B, or they can ask about this one. Those are the two that they ask, the two proofs that they ask about the compound angle identities. You can go in and check in the question paper. Some years it doesn't come, but some years it comes. So
Sorry, sir.
yes?
Sorry. With that blue pen, I can't see very well. It's too, I don't know.
Oh, all right. So I should use black.
Maybe I can't see, I have glasses.
You have glasses. All right. From now henceforth, let me use a black pen. All right. So this one is the first angle identities that I wanted us to look at. So let's go to the second one. So guys, later make a review of this this video, and from there, please, no, don't cram. No, do not cram. Okay. So now let's go to the double angle identities. Double angle. When you're talking about double angle, you're talking about sine 2A, and you're talking about cos 2A. These are double angles. 2 means double. So this one, guys, sine 2A is the same as sine A plus A. So it's a double angle. A plus A again. It's a double angle. Cos 2A, it means cos A plus A. So how do we get it? Okay, this one, I'm going to write the identities first. This one is 2 sine A cos A. Then this one is many. It is cos squared A minus sine squared A, which can be written as 1 minus 2 sine squared A, which can be written as 2 cos squared A minus 1. So these are the double angle identities that we have. And guys, these double angle identities are also examinable. Guys, they are examinable. The proofs. Okay? So, okay, I'm going to do the proofs. This one, they are short. These ones are short. Okay? So, the first one I'm going to do, given that sine A plus B is equals to sine A sine B cos B plus cos A sine B. Prove that sine 2A is equals to 2 sine A cos
Sir,
A.
I can't see clearly.
It's my handwriting. Oh, let me write again. Is it blurry, or maybe it's my handwriting? Can you see where?
Writing, sir. Yes, I
All
can
right.
see the double angle identities.
All right. Let me try to write slowly then. So, given right? That sine A plus B is equals to sine A cos B. Can you see this?
Yes, sir.
Can you see it?
Yes, sir.
Plus cos A sine B. Prove that sine 2A is equals to 2 sine A cos A. So we need to prove this, give that. Okay? So the proof goes on like this. Guys, can we all see red? Okay. No response. I'll keep on writing with black, but I wanted to use different colors. Okay. The proof now goes like this. Okay. Sine 2A is the same as what? Simply sine A plus A. Do you agree? It's sine A plus A. Right? So sine A plus A is going to be equals to, using the compound angle identity there, it's going to be sine A cos A plus cos A sine A. But remember that sine A cos A is the same as cos A plus what? Sine A. They are the same, because we are having sine A cos sine A. So this can be written as sine A cos A plus. Then we use our commutative property. When you are multiplying, order doesn't matter. 2 times 3 is the same as 3 times 2. So this is the same as sine A cos A. Okay? So now this one is a select term. So if we add sine A cos A plus sine A cos A, what do we get? It's like adding xy plus xy. What do you get? You get 2xy. So this is the same as 2 sine A cos what? Cos A. They are there. Any questions on this one? Guys, any questions? Are you okay?
No, sir, it's
Question.
fine.
It's fine. Okay, so the idea is 2A is the same as A plus A. So now A plus A becomes compound. So now sine A cos A. Cos A sine A. Right? Because now where there was B, now there's A. So there is the proof. This one is examinable as well, guys. So please know it. It's also examinable, but it's not common. It doesn't come always. The one that comes is the one for compound angle identities, especially proving cos A plus B. Okay? So now we do the last one. Given cos A plus B is equals to cos A cos B minus sine A sine B. Right. Prove. Give the proof of cos 2A. So it is important, guys, to know that cos 2A is the same as cos. Who wants to tell me? How do we write it as a compound angle? Cos 2A is the same as cos. Anyone, guys? A plus A. Right?
That's it.
So, is this okay? Are we covered, guys? All right. So, this is cos A plus A is equals to cos A minus sine A sine A. So cos A times cos A gives us cos A squared, but we write it as cos squared A. Sine A is sine squared A. Then we have proved. That is the proof. Then the other proofs, guys, is just about changing here. Cos squared A is the same as 1 minus sine squared A. The other one is which is equals to cos squared A is the same as 1 minus sine squared A. Minus sine squared A. So this one is coming from what? Double angle identities, which says cos squared A is equals to 1 minus sine squared A. That is double angle what? Identity. The one that we have talked about before. Okay? So from there, like terms. So 1 minus, remember this is minus. So it's going to be minus 2 sine squared A. That is where we get the other one. From there, from saying cos squared A is the same as 1 minus sine squared A. I emphasized it when we're starting. Okay? So the other one, so this one is the other identity. We know that cos 2A is equals to 1 minus 2 sine squared A. The other identity says cos squared A minus. Then here we know that, guys, sine squared A is the same as 1 minus cos squared A. I put brackets there because we have a minus. So if we expand the brackets there, we have cos squared A negative 1 positive cos squared A. Negative 1 times 1, negative 1. Negative times negative cos, positive. Then if we take like terms, cos squared A plus cos squared A gives us 2 cos squared A minus 1. If we take that one and that one, we add them. They are like terms. So that is the second identity. The third identity. Then we can conclude, guys, to say for our double angle identities, we have proved them. We have sine 2A, which is equals to 2 sine A cos A. Then we have sine cos, 2A, which is equals to cos squared A. We start with cos minus sine squared A, which can be written as 1 minus 2 sine squared A, which can be written as 2 cos squared A minus 1. And I've shown it where it comes from. It comes from double angle identity, whereby you replace this one by 1 minus sine squared A, or whereby you replace this one by 1 minus cos squared A. Then you get your double angle identities. So, any questions, guys? Any questions? All right. I am only left with 8 minutes, and this side load shedding electricity is going at 7. So I am going to try to prove some identities using these double angle identities and using compound identities. Right. I am going to look at some identities. Okay. So I'm going to look at the simple ones today, guys. Then if we have some time, maybe tomorrow or Sunday, then we are going to go on with them, look at more identities. And I'll tell you the tips that are very, very important so that you won't lose marks. Some marks, they are very, very, very silly to lose, guys. Because these, you are given at the formula sheet. In the formula sheet, the identities, they are there. So when you see them, it's for you to apply. Okay? So now I am going to check all the exercises that I've sent, guys, so that at least we can have 1 or 2. I am going to start by doing number A. The first exercise was exercise number 7. It was exercise number 7. Can we check, guys? Is it exercise 7? Can we check? It was exercise 7. Okay, so number A1 was saying prove the identity sine 2 theta. Was it sine 2 theta over cos theta minus sine theta is equals to tan theta tan theta cos theta. Okay? So we need to prove this, guys. How do we do that? Remember that your equation, it has two sides. It has the left-hand side and it also has the right-hand side. So when it's like this, guys, you choose the complicated side. Try to prove it until it's the same as the other side. So when it's like this, we are going to choose the left-hand side. So we are going to say the left-hand side is equals to sine 2 theta over cos theta minus sine theta. Guys, is there any identity that you are seeing there? Something that is an identity that you are seeing on our expression that we have indicated just now?
Sine 2.
Sine 2 theta, right. Sine 2 theta can be expanded as
2 sine theta cos theta.
2 sine theta cos theta over what? Cos theta minus sine theta. Okay? What's going to happen here? What's the next step, guys? If we check here, we have a common factor. Right, so what happens to common factor? Remember, common factors, they cancel when you're dividing. We say cos theta into cos theta, it gets in what? Once. Right? So what are we left with? We are now left with 2 sine theta minus sine theta. So these ones, are they not like terms? They are like terms, right? Since they are like terms, what do we do? Since they're like terms, what do we do? They subtract. Sine theta, 2 sine theta minus 1 sine theta.
Minus.
Yes. This is going to be what? Sine theta. But the problem is our left-hand side is not the same as the right-hand side. Is there anything that we can do to the right-hand side so that it can be the same as the left-hand side? Because now the left-hand side is sine theta.
Yes, sir.
Our right-hand side is equals to tan theta cos theta. Conjugate tan theta is the same as what? Remember when you see sine theta over cos theta multiplied by cos theta. What's going to happen here?
They
Cos,
cancel.
Cancel out.
yeah, they cancel out. They cross cancel. Thank you. They cross cancel because they're dividing. So we are also left with the right hand side is equals to sine theta. So we have proved that we have worked our left hand side until it gave us sine theta. We have also worked our right hand side until it gave us sine theta. Therefore, you have to give a conclusion to say, therefore, the left hand side is equals to the right hand side. Like that. Then you are done.
Sorry,
Any question?
can I ask something?
Yes.
Isn't the left-hand side supposed to give us the straight answer, that is tan theta multiplied by cos theta?
It depends. Sometimes it actually gives you a straight answer. Sometimes it doesn't give you a straight answer.
Okay, thank you, sir.
Yes, sometimes it gives you a straight answer. Sometimes it doesn't give you a straight answer. So you should know that sometimes when it doesn't give you a straight answer, you should also work the right hand side. Okay? So maybe let me go to number 2. Let me go to number 2. Should I go to number 2 or let me choose another one, because now I'm not sure whether my electricity is going to allow me to continue, because now I'm left with 1 minute, guys. So I think electricity is going. So guys, I think next time we meet, be it on Sunday or be it tomorrow, I think we should continue with this stuff, because we have to take it down deep, deep, deep. And we can also take it back to the, what do you call it, to the, the general solution, because it also applies in the general solution, guys. So I'm afraid my electricity is not, maybe it's gonna be going anytime soon, you know, ESCOM. So guys, it's better I conclude my lesson now.
Mr. TK.
Yes, sir.
Yes, I just wanted to quickly confirm while they're still on the lesson to say you can still continue with them tomorrow during that time of maths.
Tomorrow, right? Yes,
yeah,
I can.
Tomorrow. Okay.
Yes,
All right.
I can.
Thanks.
I can do that. All right. I can do that, sir. Okay. So guys, you have heard that. Let's actually take it from here tomorrow, and we do a number of these identities, so that at least we can understand how we maneuver given certain situations. I've given you this situation now, then now you know how to deal with it. So I'm going to give you a number of situations. Some, they include more or four identities, some more, I mean 2 or more identities that we've learned about. Remember that we have 4 identities. 1, quotient identity. 2, we have the square identity. 3, we have the compound identity. Then 4, we have the double angle identity. So now my electricity is gone, guys. So you can comment with any word that you got from the lesson. Okay, until we meet again tomorrow.